Hello everyone, welcome back to my YouTube channel. I hope you all are doing well and good. So the subject I'm going to be talking now is going to be relating to big data analytics, and here it's not just the subject, but I'm going to be talking about a research paper that was done to this. So the title of the paper is an overview of big data concepts, methods and analytics. So first of all, we have the introduction here. So introduction to big data is basically the definition of big data. So here big data refers to large and complex data sets that require advanced tools for processing and analyzing as well as analysis. Next one is going to be data explosion. So global data itself has grown exponentially, reaching 40 zettabytes in 2020 and the project to hit about 175 zettabytes by 2025 respectively. So next one is driving factors. Growth driver by internet applications, mobile devices, sensors, IoT, that's Internet of Things, and cloud computing. All of these are actually a major role in big data analytics as a whole. Next one is big data types. So structured, that is basically a databases such as a SQL, NoSQL, etc. Next one is semi-structured data, that is basically your XML as well as JSON files, and unstructured data is social media, videos. So these three are basically the different types of data that's going to be present as a whole. Next one is the impact. So big data is transforming industries such as healthcare, finance, agriculture, and much more to it. Next one is going to be the characteristics of big data. So first off, we have volume. So massive data sets are basically ranging from terabytes to zettabytes. See, this is basically a hierarchy of data, how it's going to be stored, right from say kilobytes to megabytes and then so on and so forth. The last one here is going to be the zettabyte, that is at the top of the hierarchy. Next one is velocity, that is the speed of data generation and real-time processing. Example is social media as well as sensor data. Next one is variety. So data comes in multiple formats, structured, unstructured and semi-structured as a whole. Next one is veracity. So this is basically going to ensure the quality and the trustworthiness of data, that is accuracy and consistency, which play a very important role in big data as a whole, because big data needs to be analyzed and hence it is known as big data analytics. Next one is value. So extracting meaningful insights and business values from raw data. Okay, so moving on, we have the applications of big data. All of this is respect to the particular paper that was being dealt with. So first of all, we have fraud detection, real-time analysis in order to identify and prevent fraudulent activities in transactions. Mainly this relates to banking transactions as well as UPI payments. Next one is call center analysis, using big data analytics to process customers' interactions and improve satisfaction. Next one is social media analysis, analyzing user behavior on social platforms to gather market insights. Next one is financial data, predicting stock market trends and enhancing the overall decision making, especially in stock markets, because it's basically a rise and fall of how much money you're putting into one particular stock. Next one is agriculture, using sensor data in order to monitor crops and improve agricultural productivity. So moving on to the next slide, we have the challenges in big data. So first of all, the most important challenge here is storage. Traditional databases struggle to handle the scale of big data, leading to the use of distributed systems and NoSQL databases. Next one is data visualization, presenting complex data in a very meaningful way that can be understood by humans as well as machines. To humans, data is actually a little complex to understand, but when it comes to machines, you're converting all of the data into zeros and ones, because that's the only way how a machine is going to understand what type of data you're going to be using. Next one is going to be redundancy reduction, eliminating duplicate information in order to optimize the overall storage and the processing. Next one is the life cycle management, determining which data should actually be retained and which can actually be discarded, because life cycle management is basically going to regard this particular thing, because you need to know how you are going to be handling the particular data, to what extent the data has to be needed and when the data has to be discarded. So the last point here is security and privacy, ensuring data confidentiality while handling larger data sets in distributed environments. So all of these 5 points are going to relate to the challenges in this particular big data. Moving on to the next slide, we have big data management tools and technologies. First of all, we have HADOP or Hadoop. Hadoop is going to stand for High Availability Distributed Object Oriented Platform. This is basically an open source framework that is going to use MapReduce and HDFS for scalable data storage and processing. Next one is Hive, a data warehouse that is going to allow SQL queries or SQL-like queries on data stored in Hadoop itself. Next one is NoSQL databases, non-relational databases like Cassandra and MongoDB, designed for handling unstructured data. Next one is RapidMiner, a tool for data mining, machine learning, and predictive analytics. Next one is visualization tools, Tools like Tableau, R and Infogun for creating interactive visualizations from larger data sets. So all of these are basically the tools and technologies used to manage the big data that is going to be present. Next one is big data and emerging technologies. Cloud computing. Cloud computing is basically platform providing scalable storage and computing power for big data analysis. Next one is IoT, that is Internet of Things. That is basically sensors generating larger volume of data from diverse sources, creating new opportunities and challenges. Smart cities and grids. Integration of IoT and big data in urban planning, energy management and public services. Next one is data centers. Advanced data centers manage and process huge amounts of data, optimizing storages and processing. Artificial intelligence, AI and machine learning are increasingly used in order to analyze big data and extract actionable insights. So all of these are big data and emerging technologies respectively. So the last one is basically the results of big data implementation. So improved data processing. The use of distributed file system like Hadoop and NoSQL databases have significantly enhanced the ability to store and process vast amounts of data. Result is basically 50% faster query processing and reduced storage cost by 30%. Next one is enhanced decision making. Big data analytics such as social media analysis and predictive financial model enable companies to make faster data driven decisions. The result here is a 20% improved in market response and customer retention through real-time insights. Next one is fraud detection efficiency. Fraud detection system leveraging big data analytics have become more accurate and proactive. Result is basically 40% reduction in fraudulent activities and faster identification of anomalies in financial transactions. So moving on, we have the continuation of this particular result slide itself. That is increased agricultural productivity using sensor data and big data analytics in agriculture has actually improved crop yields and resource optimization. Next one is the result here. That is 15% increase in crop productivity, 25% reduction in water wastage or usage through targeted irrigation. Next one is going to be scalability and flexibility. So big data platforms like cloud computing allow organizations to scale their operations effortlessly. So moving on, we have the conclusion. So what is the importance of big data here is basically crucial for transforming industries and enabling data driven decision making. Challenges ahead. So storage, security, data management and all real-time processing remain key areas for improvement. Next one is going to be technological solutions. Advancements in cloud computing, IoT and AI are going to offer new ways to handle the complexity of big data. Next one is opportunities. Big data will continue to drive innovation in fields like healthcare, finance and smart cities. Next, the last point, that is future research. So standardization, security mechanism and real-time analytics are areas where further development is to be needed. So I hope you understood what all the topics were being dealt in this particular video, right from the introduction to big data, the uses of it, the tools, the methodologies, as well as the emerging technologies and much more. So I hope you really enjoyed this video and thank you for watching.